up to note card number 11, and this is the slope formula. Now, you did slope formula last year, so this is review, but I just want to make sure you have all the formulas down on a note card. So the way you find slope is you take y2 minus y1 and then divided by. So this is kind of like the distance formula. They're in two ways. Number one, you subtract, and number two, we're starting with the y's. So distance formula and slope formula, they both start with the y's, and they both subtract. Midpoint formula is different. It adds and starts with the x's. Okay, but this is slope formula. So it's y2 minus y1, and then it's divided by x2 minus x1. And that's the entire formula. So this one's easier than the distance formula and a little bit easier than the midpoint formula. Okay, then remember yesterday we learned that when you take y2 minus y1, that figures out how far apart they are. So like if one is 3 and the other one's 8, they're 5 apart. So sometimes we refer to that as the change in y. And the triangle stands for change in. And same thing with the x's. When you subtract them, you figure out how far apart they are. So sometimes we refer to that as the change in x. Okay, so that's everything for the note card. But I want to remind you about perpendicular lines. Remember yesterday we wrote down perpendicular lines. Those are two lines that hit at 90-degree angles. Perpendicular lines have opposite reciprocal slopes. So what that means is one of them is positive, one of them is negative. And then also that it's the fraction flipped. So if this one is 7 over 3, the other one's going to be negative 3/7. Okay, so that's just a reminder that if the lines are perpendicular, if they hit at a 90-degree angle, then the slopes are going to be opposite and reciprocal. Okay, now today's paper, I'll pass out the whole bunch in a minute, get out a sheet of paper. Today's paper is called Coordinate Geometry Day 2, and we are starting with number 10. You don't have to write these points down because it's part of the question. So just write down the title and your name. And we're starting with number 10. And I'm going to start with part A. And this is the question. You still don't have to write this down. The question is AB, and then this symbol, and then CD. Okay, so first of all, raise your hand if you can tell me what this question is asking. Yeah, Taylor? Good. Is AB perpendicular to CD? And remember, when there's a line on top of it, it stands for a line segment. So you could be a little more technical and say, is line segment AB perpendicular to line segment CD? Okay, so we're not going to graph, but just to give you an idea of what's going on, if we connected from A to B, we'd get a line segment. And if we connected from C to D, we'd get another line segment. And the question is, do these line segments hit at a 90-degree angle? Is it perpendicular? Okay, so since we're not graphing, instead we're going to use the slope formula to figure out if they're perpendicular. And so we're going to figure out the slope from A to B, then we're also going to figure out the slope from C to D. And then if those slopes are flipped opposites, then we'll know they're perpendicular. Okay, so for the slope from A to B, that's -6 minus 5. So for slope, you subtract the y's and subtract the x's. So I'm just doing that number minus that number over that number minus that number. Y's come first. That's why they're on top. And it's subtraction, because it's not the midpoint formula. The only one that's add is the midpoint formula. Okay, -6 minus 5 is -11. And then -3 minus 8 is -11. And then -11 divided by -11 is 1. So that means the slant from A to B, the slant of it is 1. How steep it is. Okay, now we're going to find the steepness from C to D. So 6 minus -5, excuse me, and -3 minus 8. Six minus -5 is 11. -3 minus 8 is -11. And then positive 11 divided by -11 is -1. So this line here, its slant is -1. Okay, so the question is, are they perpendicular? So two things have to happen. That they have to be opposite, which they definitely are, because this one's +1 and this one's -1. And then they have to be the flip of each other. So if you had to force 1 to be a fraction, that would be 1 over 1, because 1 divided by 1 is 1. So the flip of that is still 1. So flip this, you get 1, then take the opposite, you get -1. So these are opposite reciprocals of each other. So because of that, that means the answer is yes, it is perpendicular. So yes, the slopes are opposite and reciprocal. Okay, so that was part A. It was asking, is line segment AB perpendicular to CD? We got yes, and that's why. Okay, here's the next question. It's part B. Is, bless you. So raise your hand if you can tell me what this question's asking. Yes, Maddie? Good, so this is the symbol that means parallel. So the question is AC parallel to BD? And the way you can tell if they're parallel is if they have the same slope. Okay, now this time they switched and they're connecting A to C. So we'll do the slope from A to C. So that's -5 minus 5. Over 8 minus 8. -5 minus 5 is -10. Eight minus 8 is 0. and then you're not allowed to divide by 0. So when you try, like this question's asking you to, there's not an answer. So we say undefined. And you might remember this from algebra, you might not. An undefined slope is a line that's going straight up and down. It's very, 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 very steep. It's a cliff. So it's crazy steep, so we say you can't even talk about how steep it is. It's an undefined slope. Okay, so from C to D it's undefined. Now we're going to go from B to D and figure out the slope there. So that's 6 minus negative 6. And negative 3 minus negative 3. Six minus negative 6 is 12. Negative 3 minus negative 3 is 0. You're still not allowed to divide by 0. So this answer still doesn't even exist or is undefined. So that line segment is also straight up and down because it has an undefined slope. So they have the same slope, and if you have two lines that have the same slant to them, then they're going to be parallel. So the question was, is AC parallel to BD? And the answer is yes. The slopes are the same. Okay, now part C says do AB and CD intersect at their midpoints. Do AB and CD intersect at their midpoints. So they're kind of already telling us that they hit each other. And so the question is, when they hit each other, is it in the exact middle? So here's our picture over here. You could have a line segment that hit another line segment not in the middle. So the question is, are they hitting in the middle of each other? So to figure out that, I need to know what the midpoint is. So now I'm going to turn my attention back to these two, A and B, and I'm going to calculate the midpoint. Okay, so that's yesterday's formula. The midpoint you add, and you start with the x's. So 8 and negative 3. So it's negative 3 plus 8. And then you divide by 2. This is the midpoint formula, finding the exact middle between these. So negative 3 plus 8 divided by 2. And then there's a comma. And then negative 6 plus 5 divided by 2. So here I'm finding the exact middle between A and B. Negative 3 plus 8 is 5. And then 5 divided by 2 is 2.5. So the x-coordinate for the midpoint is 2.5. Then negative 6 plus 5 is negative 1. And negative 1 divided by 2 is negative a half. So that point right there is the exact middle in between A and B. And now we're going to find the exact middle in between C and D to see if it's the same point. Because if they're exact middles, then it has to be the same midpoint. Okay, so between C and D it's negative 3 plus 8 divided by 2. And then those are the x's. And then 6 plus negative 5 divided by 2. Negative 3 plus 8 is 5. 5 divided by 2 is 2.5. So it's matching up so far. But then 6 plus negative 5 is 1. And 1 divided by 2 is 0.5. So the second number doesn't match up because this was a negative 0.5 and this one was a positive 0.5. So that means the answer is no this time. They don't meet at their midpoints. Okay, just one more part to number 10, part D. Part D says, are line segment AB and line segment CD congruent? Everything good? Yeah, thanks for asking. Okay, so are they congruent? We've only used the word congruent once. So congruent means same size and same shape. So if the two figures were both triangles, then they'd be the same shape. So these are line segments. So they're both line segments. So they're definitely the same shape. So now we just need to see if they're the same size. And the way you tell the size of a line segment is that's based on how long it is, the length of it. So to see if this is the same size as that, we have to find the length of both of them, and that's the distance formula. Okay, so that's the best formula. We're going to find the distance between A and B. So we're back to starting with the y's, and we're back to subtraction. So negative 6 minus 5, and also negative 3 minus 8. If it was slope, we would take this and divide it by that. But since it's distance, we're squaring them and adding them. So we're trying to figure out if they're congruent. Congruent means same size and same shape. They're both line segments, so we know they're the same shape. We're just checking to see if they're the same size by looking at their lengths. Okay, so negative 6 minus 5 is negative 11. And negative 3 minus 8 is also negative 11. So when I do the first step, I usually just do one thing. I subtract everything. And then we're going to eventually square those and add them. And negative 11 squared is positive 121. And then 121 plus 121 is 242. And then you take the square root. So the length, or the size, or the distance for line segment AB is square root 242. Okay? So you got 15.55. So after the 5, there's a, a 6, so that means you'd have to round this to a 6, right? Yeah, because if the number after it's bigger than or equal to 5, you round it up. Okay, so now we have to find out, we've just figured out the size of AB, now we got to figure out the size of CD. So that's 6 minus negative 5. And negative 3 minus 8. Six minus negative 5 is 11. Negative 3 minus 8 is negative 11. So you can kind of tell already that it's going to come out to the same, because 11 squared is 121. This is going to be 121. So save us some writing. We can already see it's going to be the square root of 242. So that means that the length, or the distance from C to D, is square root of 242. And the length of the distance from A to B is square root of 242. So those two line segments are the same size. And also, they're obviously the same shape because they're both line segments. So they're both the same size and the same shape, so that makes them congruent. Okay, so the answer here is yes, they are the same size and same shape. Okay, so that's definitely one of the longer problems. So I'm just trying to skip around here and help you with the ones that I think are going to be tougher, so you won't be too bogged down when you try to work on your own. And actually, this worksheet, it starts with number 10. So we got 10 through 16. And we already finished number 10. And now we're going to skip to 14. And we're going to work on that. Okay, so here's 14. 14 has 3 new points. J is negative 10, negative 6. K is 0, 6. And L is 6, 1. And the question says, by means of slope, so using the slope formula, show that triangle JKL is a right triangle. So they're saying that it is a right triangle, and they need you to verify that that's true. Okay, so to help us visualize, let's draw a right triangle. A right triangle has a 90-degree angle. And J is here, and K is here, and L is there. So how can I use slope to verify that this is a right angle? How will the slopes compare to each other when you have a 90-degree angle? Okay, let me try a different word. 90-degree angle means perpendicular, right? So if they hit it at 90, it's going to be perpendicular. So how can you verify with slope that the lines are going to be perpendicular?
We have to use a formula.
Yeah, I mean, we're going to use the slope formula,
Okay.
and we're going to get 2 answers. So my question is, how will you tell if it's perpendicular or not based on those 2 answers? Yeah. And there's the other fancier word. Good, thank you for being willing to say opposite. So that's awesome. So it's got to be opposite, and what else, Charlie? Reciprocal. Okay, so we're going to get our two slope answers and see if it's opposite reciprocal. Okay, so we're going to do the slope from J to K. I'm serious, I'm not kidding. I know. It's not very funny, I know, but thanks for laughing, Connor. I appreciate it. It's better than the math. Okay, so I'm not kidding. We're going to find the slope from J to K. We're going to do 6 minus negative 6. So y minus y. And then x minus x, so 0 minus negative 10. And 6 minus negative 6 is 12. 0 minus negative 10 is 10. And then 12 tenths reduces to 6 fifths. So that tells you how slanty the line JK is. It tells you how steep it is. Apparently it's going up 6 over 5. Okay, now I'm going to find out the slope for KL. So 1 minus 6 and 6 minus 0. 1 minus 6 is negative 5. 6 minus 0 is 6. So that answer is negative 5/6. And these are opposite from each other, right? Because this one's positive and that one's negative. And they're also reciprocals because this one is 6 over 5 and this one is 5 over 6. So that means that we know for sure now that that's going to be a right angle. It's perpendicular. So perpendicular since the slopes are opposite reciprocal. Excuse me. Okay, there is a part B for number 14, so you need to leave some space for that. And now I'm going to look at 15. And I'm going to finish that one, so I'll cross that off. Just kind of keeping track of what you're going to have to do after you leave here. Okay, so 15 says there are 3 forms that an equation of a line can be written in. There are 3 forms that the equation of a line can be written in. And the question is, what are they? And then give an example of each. So this goes back to algebra. You might not remember. It's been 3 or 4 months, but let's give it a shot. What's one form for a line? Yes?
A line segment?
Okay. Part of a line is a line segment, yeah. But what I'm looking for is an equation for a line.
Midpoint line.
You can find the midpoint using one of our equations from this year. That's good. You can use slope. You're on the right track for this year. But I'm talking last year where you had a line. Okay, yeah, Taylor. Yeah, so the fancy word for a line is that it's linear. That's good. So we're looking for a linear equation. I don't know if anybody's going to think of this. Okay, yeah, sure, why not? Okay, good. One of them is y equals mx plus b. Awesome. I thought it was somewhere in there. Okay, so when you have y equals mx plus b, that's called slope-intercept form. And the reason it's called slope-intercept form is because the m is the slope and the b is the y-intercept. So for a specific line, so for an example, you're going to have a number in those 2 places. So maybe the slope is 1/5 for this line. And maybe the y-intercept is -7. Okay, so this is the general template for a line called the slope-intercept form. And then this is an example of it. Okay, so y equals mx plus b is one form, and that's usually the only one people remember. The next one is slope or sorry, point slope form. And it looks like this, y minus y1 equals m times x minus x1. Maybe you don't remember this one at all. This is called slope, or point slope form. Yes? Yes, good. So the last one is standard, and I'll write that down in a second. Good. All right, so this is m, it's still slope. So maybe for this line, the slope is 8. So for a specific line, there's going to be a number there. And then these two are going to be numbers, and it's a point that the line goes through. So maybe the line goes through the point 1, comma 2. So then this would be a 1, and that would be a 2. Okay, so this is point slope form. This is the general template, and then this is a specific example. Okay, then Jennifer's right. The last one is standard form, and that looks like ax plus by equals c. And in that case, the a and the b and the c are going to be numbers. So maybe the a is 3, and the b is -5, and the c is 12. I don't know. This is just a specific example. Okay, so when you write the equation of a line, you have 3 options. You can use slope-intercept form, point slope form, or standard form. And then they would look like this for specific examples. Okay, so there's only 1 minute left, so I'm not going to pass out the paper, but you have to go on to classroom and finish that up.